right, so I first want to start off with today. It's day 2 of applications, and I want to kind of sum up what we talked about in class. The big thing I want you to take away from doing applications of quadratics is understanding when they ask certain questions, what part of that quadratic are they asking you to find? So the big 3 questions that you will see are going to be how long till it reaches the maximum height, how high up will the object reach, and how long till the object hits the ground. Those are the big ones. And so one of the things you got to remember is if you have ax squared plus bx plus c, c is the initial height, how high off the ground it was when it left, wherever it left. B is going to be your initial velocity, or how fast it took off. And A is always going to be that acceleration due to gravity. So either negative 16 feet per second squared or negative 9.8 meters per second squared. So when we talk about maximum height, we want to take a look at how long it took to get there. So that how long piece is really, when we talk about that parabola, we're talking about how long, because time always runs on our x-axis. We're really talking about axis of symmetry. So if we ask that, and remember that's going to be your x equals opposite of b over 2a. If we're talking about how high up the object will reach, that means we're talking about this point here, which is going to be your vertex, specifically the y-coordinate, which, remember, that's going to be when you take your negative b or opposite b over 2a and we stick it back into the function. That's going to be this piece right here that we're looking for. And if we talk about how long until the object hits the ground, we're talking about this point right here. And this is when we say our zeros. You will have 2 of them. One of them will either be 0 or it'll be negative, which won't make any sense. So it's specifically talking about this one. And that's when we're going to either factor, which we'll check for first, or we'll use our quadratic formula. So let's take a look at this example. I've just got one example today. We got a basketball shot with an initial velocity of 24 feet per second from 6 feet off the ground. Ball's height in h in feet is modeled by this function, h of t equals negative 16t squared plus 24t plus 6, where t is the time in seconds after the ball is shot. I'm not going to actually expect you to graph these in terms of super superior accuracy. I'm simply looking for a sketch so we can figure out what it is we're looking at. So if we think in terms of 1, 2, 3, 4, 5, 6, this ball is doing something like this. So, like I said, I just want an idea. It's basically we're shooting the ball, ball's missing the basketball hoop, which is right here, and bricking it, and poor child, we've got a missed shot. So when does it reach its maximum height? So we're looking in terms of time versus height. So when we're looking for this point here, which means we're looking for this x value here. So we are looking for our axis of symmetry. So that means when we look at our equation, we're looking at x equals the opposite of b, so negative 24 over 2 times a, so 2 times negative 16. Well, negative 16 times 2, so that means we have negative 24 over negative 32. We're not going to leave it as a fraction because when we want to know time, we want it relatively accurate. So we'll take 24 divided by 32 since a negative divided by a negative is positive, and we get 0.75. That's in terms of time because it says when, so we want to make sure that we use seconds. So it takes less than a second before that ball actually reaches its maximum height. Then we want to know what is the maximum height of that ball. So now that means we want to know how high up it was. That means we want our y-coordinate of our vertex. So that means we need to take our 0.75 and we need to substitute it back into our function of negative 16t squared plus 24t plus 6. So we go here and we put in negative 16 times t, which is 0.75 squared, plus 24 times 0.75 plus 6. And so now we just calculate. 5 squared is 0.5625, so I have negative 16 times 0.5625 plus 24 times 0.75 plus 6, and I'm going to do it piece by piece just to make sure I don't miss anything. So we take the negative 16 times 0.5625, and we get negative 9. And we take 24 times 0.75, and we get 18. And then we have our plus 6. Negative 9 plus 18 is 9, plus 16 is 15. So 15 feet would be how high that ball gets. So if we looked in terms here, obviously our graph is a little bit inaccurate. We should be going up to about here. But like I said, it's a sketch, and we just want to use it for that approximation. What I want you to do now is to take this problem, similar to the you try problem that we did at the end of today's lesson. Same problem, we have Emilio throwing the javelin. What I want you to find today is the maximum height that the javelin reaches and how long it will take to reach its maximum height. And as always, bring your questions with you to class.